Why is humanity suddenly obsessed with the 11-kilometer abyss beneath us? It's pitch black, near freezing, with water pressure high enough to crush a submarine like a soda can. By all rights, it should be a dead zone. Yet, we found life thriving in the darkness. That moment shattered our understanding of biological limits forever. Today, the Mariana Trench isn't just a curiosity, it's a strategic frontier. Whoever can reach, map, and deploy infrastructure here will dominate the next era of deep-sea exploration and resource management. This is no longer just science, it's about who holds the keys to the ocean floor. So today, we aren't just talking about the deepest point on Earth. We're asking, why is this silent, dark abyss becoming the most important place on the planet? To understand the Mariana Trench, you first have to grasp its staggering scale. If you dropped Mount Everest into the Challenger Deep, its summit would still be submerged. By over a mile of water. This trench is a 2,550-kilometer scar on the Earth's crust longer than the entire US West Coast from Seattle to San Diego. How was such a massive wound carved into our planet? The answer, a slow-motion collision of tectonic plates lasting millions of years. Think of the ocean floor as giant conveyor belts are tectonic plates. 700 million years of movement led the Pacific Plate here. At this spot, its journey ended as it slammed into the smaller Mariana Plate. Because the Pacific Plate is older, colder, and heavier, it can't rise. It's forced to subduct, diving deep into the Earth's fiery interior. This violent process is called a subduction zone, where the plate bends and snaps. The deepest, darkest scar on Earth's surface is born. For centuries, its depth was only a legend, until the HMS Challenger first measured it in 1875. Sailors dropped weighted-sounding lines, thinking they'd hit bottom quickly. Instead, the rope kept slipping into the abyss, spool after spool. Hours later, they hit bottom at nearly 8 kilometers deep. The number was so extreme that many refused to believe it. But humans wouldn't see it with their own eyes until January 23, 1960. The bathyscaphe was called the Trieste. It wasn't a normal sub. It was an underwater blimp designed for one job: reaching the bottom. In a cramped steel sphere only 1 meters wide sat two men, Swiss engineer Jacques Piccard and Navy Lieutenant Don Walsh. Their goal? Reach the Earth's basement. As they sank into the soul-crushing dark, the temperature dropped to freezing. At 9,000 meters, a loud crack echoed through the cabin. An outer window pane had fractured under the weight. At this depth, a hull failure isn't a leak, it's a catastrophic, instantaneous implosion. With their lives on the line, they made a terrifying choice: keep going. They descended the final mile to the bottom, becoming the first humans to ever witness Earth's final frontier. But the Trieste had to fight more than just depth. It had to survive the pressure. At sea level, we feel 1 atmosphere. At the bottom, it's over 1100 equal to 1 tons per square centimeter. To visualize this, imagine the entire weight of an adult elephant concentrated on the tip of your thumb. Across your entire body. That's like carrying the weight of the entire Brooklyn Bridge. Even the crushing atmosphere of Venus is less than 1/10 of the pressure found here. Under this weight, the molecules of life warp. Calcium, which forms our bones and seashells, simply dissolves. Even the proteins that drive metabolism are distorted. This place doesn't just hate life, it forces life to rewrite its own rules of survival. Yet, when Piccard and Walsh looked through that cracked window, they saw the impossible: a flat, ghostly creature swimming calmly through a world meant to kill everything. This glimpse shattered our long-held biological worldview. If life can thrive here, what other impossible limits can be broken? Leaving the sunlit surface behind, we plunge deeper into the unknown. First stop, the Twilight Zone, a realm of eternal, deep blue. Here, the last rays of sunlight fade, and the laws of survival begin to warp. Survival means hunting for the very last available photons. Life evolved two ways here: either grow massive, ultra-sensitive eyes, or learn to create your own light. This is the kingdom of bioluminescence, a cold, chemical glow used to hunt, hide, and mate in the encroaching dark. The pressure here is already immense. The water, bone-chillingly cold. Take the hatchetfish, blade thin, with giant, tubular eyes that stare upward to catch the silhouettes of prey above. To hide from below, its belly glows with light that mimics the faint blue surface, achieving perfect optical stealth. At 1,000 meters, we enter the midnight zone. Sunlight is gone. From here to the bottom, the only light is made by life itself. In this eternal night, vision becomes useless. Senses are reshaped. Many creatures are covered in pressure-sensing cells to detect the slightest ripple in the water. At 100 kilograms of pressure per s. The Gulper Eel, for instance, evolved a massive, unhingable jaw and a stretchable stomach to swallow prey much larger than itself. When your next meal might be months away, this is a survival masterstroke. This environment breeds alien-like efficiency and bizarre forms. We've seen the odd survivors of the midnight zone, but before we hit the crushing depths of the hadal zone, we must solve a mystery. How does life survive with no plants or sun? The answer isn't below. Life here feeds on marine snow, constant blizzard of organic debris, dead plankton, and waste that drifts down for weeks. Only 5% of this snow reaches the bottom, but every few decades, a miracle happens. A whale fall. When a 40-ton whale carcass sinks, it creates an oasis that supports a complex ecosystem for over a century. First sharks, then crabs, and finally, the Ozdax, bone-eating worms that dissolve the sky. But the journey continues. Below the abyssal plains, at 6,000 meters, we enter Earth's most mysterious realm, the hadal zone, named after Hades, god of the underworld. This is the exclusive territory of deep-sea trenches. Here, we find the Mariana snailfish, a pale, ghostly creature, and one of the deepest dwelling fish known to man. Its body is gelatinous, its bones soft and flexible to survive pressure that would turn. This isn't just adaptation, it's a total biological redesign. Even more strange are the xenophyophores, giant, single-celled organisms the size of a fist. They thrive where cell structures should collapse. Along with microbes eating crustal chemicals, they reveal the ultimate law. When light dies, life feeds on the planet itself. We've reached the bottom, a place of terrifying pressure and bizarre life that rewrites our biology books. For centuries, this was just a playground for scientific curiosity. But whenever humans find it, the significance of the Mariana Trench is no longer just about what lives there, but why. It's suddenly a global priority. After the 1960 Trieste dive, the trench was ignored for half a century, harder to reach than the moon. The silence broke in 2012 when James Cameron made his solo dive, reminding the world of this hidden frontier. Then, Victor Vescovo's repeated trips starting in 2019 increased the frequency of human par. It's the transition to systematic, repeatable deep-sea operations. China's Fendu's lander reaching 10,000 meters signals a new era. It's not just about getting there once, it's about staying there. More importantly, nations are deploying OV's autonomous underwater vehicles. These robots map the floor, analyze sediment, and patrol for months at a fraction of the cost of manned subs. The deep sea is transforming from an explorer's dream into a space for long-term study and deployment. And once a space becomes accessible, its meaning changes instantly. What is driving this new deep-sea gold rush? The answers are raw resources, infrastructure, and future dominance. The abyssal plains are littered with trillions of potato-sized polymetallic nodules. These aren't just rocks. They are rich in cobalt, nickel, and manganese, essential for EV batteries, wind turbines, and smartphones. Whoever masters the surveying and harvesting of these resources will hold the keys to the future's green energy supply chain. This is why deep-sea mining has moved from sci-fi to high-stakes boardrooms. But herein lies the crisis. Current mining methods act like giant vacuums on the seafloor, potentially destroying fragile ecosystems that take eons to recover. Humanity's first real chance to reach this place is also our first real chance to destroy it. Beyond minerals, the ocean floor hides the modern world's true nervous system. Subsea fiber optic cables. Our entire global economy, finance, and internet traffic depend on these vulnerable, deep-sea lines. As our ability to map, sample, and patrol the deep increases, we gain more than just science, we gain deep-sea situational awareness over the world's most critical infrastructure. The abyss is no longer a wilderness, it is a vital extension of our physical world. Complicating this is the fact that many of these areas lack clear legal frameworks. High seas are the common heritage of mankind, but the rules for resource use and environmental protection are still being written in real time. Those who reach the bottom first, map it first, and build the capacity to stay, will likely dictate the rules of the future. The Mariana Trench is more than a geographical wonder. It's a microcosm of the 21st century human dilemma. It is a fragile natural lab holding secrets to the origin of life and extreme adaptation. Yet it is also the new frontier where technology, resources, and geopolitics collide. For the first time in history, this dead end is within our reach. Dozens have now reached the Challenger Deep, but reaching it is not the same as understanding it or respecting its limits. As more powers descend into the abyss, a vital question emerges. Will we treat this final frontier as a shared scientific laboratory for all mankind? Or will we push exploitation faster than our capacity to understand? The race to the abyss has begun, but more important than who gets there first is how we choose to face the deep, unfamiliar darkness of our planet. I'm your host for Midnight Cosmos. Good night.